Hi everyone, we're going to find the intervals of increase or decrease, find the local max and min values, find the intervals of concavity and the inflection points, and use our information that we obtained to sketch the graph. And you're also welcome to check with your graphing display calculator. All right, so the first thing we're going to do is find the intervals of increase or decrease. So we want to find what's going on with that by taking our first derivative. And then we can figure out our local min and max. So for the first derivative, f prime of x, we're going to get 36 plus 6x minus 6x squared. All right, and let's fix that up because we're going to have to set this to 0 to find our critical values. So I'm going to pull out a negative 6. I'm going to flip this around. So that's going to give you x squared minus x minus 6 equals 0. It's a little easier to factor that way. And then when you factor, you're going to get x plus 2 and x minus 3 equals 0. So your critical numbers are x equals negative 2 and x equals 3. So now to find out what's going on between these numbers, we do a little line graph. And I'm going to put negative 2, 3, and I want to know what's going on when x is less than negative 2 on the graph. Remember, this is your x graph. When it's bigger than 3, the number is bigger than 3, and when the number is in between negative 2 and 3. So I'm looking at, and I already have my critical numbers, I should write them somewhere else. So that's going to be critical numbers are negative 2 and 3. We already have them written down. So basically, we already have a negative here. So I'm going to keep that negative there. Now let's say for this, in this area of the interval, let's plug in negative 3. If I plug in a negative 3 here, that's going to give you a negative number. If I plug in negative 3 in this one, that gives you negative. 3 negatives make a negative. Now let's plug in, for this one, let's go ahead and plug in 0. So I still have my negative for this. If I plug in 0, I'm going to get positive. Plug in 0, I get negative. 2 negatives make a positive times a positive. This gives you positive. All right. And then the last one, let's plug in 4. I have a negative. If I plug in 4 into this, I get positive. Plug in 4 in here, I get positive. So we get negative times a positive is negative. So basically, our interval from negative infinity to 2 is decreasing. So that's the decreasing interval. And from negative 2 to 3, it's increasing. And then after 3, it's decreasing. We don't really know what's going on after that, but that's what's going on. It's decreasing there, and it keeps on. So you can see clearly we have a minimum here and a max here. Now, to find the values, we have from negative infinity to negative 2, that's a local min, a min. And then you just find your y value by plugging in that negative 2. You get negative 44. So that point, we're going to graph it. It's negative 2, comma, negative 44. And then for this one, our max, that's occurring between, let's see, negative 2 to 3. That's your local max. So this is occurring at 3, so f of 3 equals 81. I already plugged in the values before I did the video to make it easier. So this is going to be 3, 81. Basically, you're just plugging these values into this. You can use your calculator if you want. So we'll be graphing our local min and max. Now we've got to check for C, the inflection points, and find the intervals of concavity. So I'm going to have to take the second derivative. I'm going to go ahead and do it on this space here and then move on. So the second derivative of this piece is going to be 6 minus 12x. All right, so let's write that down. So our second derivative of x is 6 minus 12x. Set that to 0. You're going to get 6 equals 12x. And so x is just going to equal 1/2. All right, so what we want to do for our concavity is we're seeing if it concaves up or down. So I put my 1/2 here, and I want to see what's going on when x is less than 1/2 and what's happening when x is greater than 1/2. Now, let's plug in 0. If I plug in 0 in this, I'm going to get a positive number. If I let's plug in 1, I'm going to get negative. So that basically means it's concave up. I'll do it over here. Some kind of graph that's concave up. And then it starts concaving down like this. But as you notice, our interval here is still increasing. But an inflection point is the change in concavity. So the intervals of concavity are negative infinity to 1/2 and 1/2 to infinity. And then the inflection point, all you do is you take your f of 1/2 and plug it back into this equation, your original equation. That gives you 37 divided by 2. And let's know what that is. That's 18 and 1/2. And then we can graph it. We have 3 points to graph. We're graphing our inflection point and our min and max values. Now I took the liberty of sketching the graph. Now remember when they say sketch a graph, that means there should be no grid. Now I put a grid on here. It just helps me graph on the iPad. But usually you don't have to be that precise, and I wasn't that precise. Because you can see my y values are kind of squished together. So let's just take it. I'm just giving you a general sketch of the curve. So here's your max. We already got that. So we're doing a decreasing interval to -2. We evaluated -2 and got -44. Then this is our inflection point. So we're concaving up. Let's see, concave up. Then we're concaving down. And then we're decreasing after 3. Decreasing interval. So this is decreasing. These are both increasing, but the concavity is concave up and concave down. All right. So that's it. Thank you. Have a nice day. Bye-bye.